Hi. Today we will see about hypothesis testing. In today's data-driven world, decisions are based on data all the time. Hypotheses play an important role in that process, whether it may be making a business decision or making a decision in healthcare sector, academia, or in quality improvement. Hypothesis tests are used to support making decisions by helping to understand whether the data collected from a sample of all possible observations support a particular statement about a population. So why we are why we are going for a hypothesis test means in real time it is not possible to take a decision whether the statement is true or not by considering the entire population data. So that's why we are taking a sample data. So from the sample data we are making some decision and we are mapping that decision to that population. So a statistical hypothesis is a statement about the parameters of one or more populations. The parameters may be either mean, variance or proportion or something else. So when we go with hypothesis testing, there are two types of hypothesis. One is null hypothesis, another one is alternate hypothesis. So null hypothesis always defined by using the equality operator. That is always it is defined by using the equal operator. And alternate hypothesis may be either it is not equal or that is greater than, or it may be it is less than. The alternate hypothesis is the logical opposite of the null hypothesis. So here we will understand the null and hypothesis by giving some statements. So the first statement is the mean number of years American works before retiring is 34. Here the parameter of interest is mean. So we are defining H0 as mu naught equal to 34, and the alternate hypothesis is mean not equal to 34. So if you are using alternate hypothesis not equal to, here the two-tailed test is used. Another statement is a private university's mean tuition cost is more than $20,000 per year. So here the parameter of interest is also mean. So here we are using the operator mean and the amount is $20,000. So in null hypothesis mean equal to 20,000, and alternate hypothesis in the statement the tuition cost is more than $20,000. So here we are using the greater than operator. That is alternate hypothesis is the mean is greater than $20,000. So in that case we will use the right tail test. Another statement is fewer than 5% of adult ride the bus to work in Los Angeles. So here we are using the proportion. So the interest of the parameter is a proportion. So here we are using the symbol P to represent the proportion. It is a 5%. So the proportion equal to H0, that is null hypothesis P equal to 0.05, and the alternate hypothesis P is, here we are using that term fewer than, so here we are using the less than operator. So the alternate hypothesis is P is less than 0.05. Then the test used is left tail test. Then what is the different steps to test the hypothesis? So the first step is we have to decide the parameter of interest, whether the statement is about the population mean or variance of the population or proportion of the population, like that. Next one is we have to define the null hypothesis, then alternate hypothesis. After deciding the null hypothesis and alternate hypothesis, we have to determine the appropriate test statistics. So either they may be a Z test, or it may be a T test, or it may be a chi-square or ANOVA test. So depending upon the problem statement, we have to decide the test statistics. After computing the test statistics, we have to state the rejection criteria for the null hypothesis. So the rejection criteria may be, that is defined by using the alpha value or p value. Okay, so based on that alpha value or p value, that hypothesis may be rejected. Then here we have to compute the test statistic value. Then based on that test statistics and that this rejection criteria value, we have to come to a conclusion. So this is the different steps in hypothesis test. So the result of a hypothesis test is either to fail to reject or reject the null hypothesis. So when we reject the null hypothesis or fail to reject the null hypothesis, there may be a possibility of error. So that may be either type 1 error or type 2 error. So what is type 1 error? Reject the null hypothesis when it is true. So what is type 2 error? Accept null hypothesis when it should be rejected. So this is one sample of test statistics. When we use t-test statistics means we are estimating the mean population. We are estimating the mean population. Then variance of the population is unknown. We will use the t-statistics. So what is the formula to compute the statistical values? Mean of the sample. Mean of the sample. Then this is the population mean, that is the subject of the hypothesis test, and this is the standard deviation of the sample. This is the number of objects in the sample. So we will see one example. So here the average shampoo bottle volume measured over the 100 samples is 199.94 and the standard deviation is 0.613. That is the mean, sample mean and sample deviation, and the number of objects in the sample is given. So our hypothesis test is test the mean of the population is 200 with the significance level of 0.05. So alpha equal to 0.05 and that mu equal to 200. So what is our null and alternate hypothesis? So null hypothesis is mean equal to 200 and alternate hypothesis is mean not equal to 200. So here the population variance is not known. So we will use the t-test statistics. So that is equal to mean of the sample minus a population mean, that is the we are going to test. This is sample standard deviation and number of object. So this is the test statistics value, that is minus 0.979. We have computed the test statistics value. Then we have to take the table value. So how we are taking the table value means this is a two-tailed test. So if it is not equal to, here we will use a two-tailed test. So here we are using the two-tailed test. In two-tailed test we are computing the value for the degrees of freedom 99. So here n equal to 100. So for the degrees of freedom 99, for the alpha value 0.05, we are checking what is the value of table value. It is 1.984. This is 1.984. So the table value is 1.98. Next we have to decide whether we have to accept the null hypothesis or reject the null hypothesis. So this is a two-tailed test. So the rejection value, so this is our table value is 1.98. So our acceptance region lies between 1.98 to minus 1.98. So this is the acceptance region. If the computed value falls within that range, we can accept the null hypothesis. So this is the computed value. It is minus 0.979. So minus 0.979 lies in the acceptance region. So we are accepting the null hypothesis. So what we are concluding is the population mean is 200. Okay. We will see one more example. So the mean standard deviation of basefall coefficient of restitution of 15 sample or 0.83725 and standard deviation is 0.02456. It is of interest to determine whether there is evidence with alpha equal to 0.05 to support a claim that mean coefficient restriction exceeds 0.082. So here our null hypothesis is 0.0, mean equal to 0.82, alternate hypothesis mean is greater than 0.82. Here it is exceeds 82. So here we are defining alternate as mu naught is greater than 0.082. Then the computed statistical values 2.72. Then we are taking the table value by using one-tailed test. With the degrees of freedom 14. So n equal to 15. So with the degrees of freedom 14. So with the degrees of freedom 14, for the alpha value 0.05, the table value is 1.76. So 1.76. So the computed values are 2.72. If it is a one-tailed test, we are using a right-tailed test. This portion is called as acceptance region. This is called as rejection region. If the value falls within that accepted region, we can accept. Here this 2.72 is greater than this 1.76. So we reject the null hypothesis. So reject H0 and conclude that the mean coefficient of restitution exceeds 0.82. Okay. So this is how to define a hypothesis, how to compute the statistical value, and how to take the table value. Based on the table value and computed value, either we can accept or reject the hypothesis. So there is another way to accept or reject the null hypothesis, that is based on p-value. So the hypothesis may be accepted or rejected either by using the alpha value or by using the p-value. So what is a p-value means? That is the percentage of risk in rejecting the null hypothesis. So p-value defines the risk in rejecting the null hypothesis. If p-value is very less, that is there is a less amount of risk, so we can reject the null hypothesis. If p-value is very high, there is a risk, so it is not possible to reject the null hypothesis. So reject the null hypothesis if p-value is less than alpha value. Okay, so we have seen two different problems. In the second problem, that mu naught is 0.82, alternate hypothesis is mu is greater than 0.82, then n equal to 15, and the computed value is 2.72. So how to compute the p-value means, again we are using the same one-sided table. So how we are calculating the p-value means, so here we are considering the degrees of freedom 14. So in the degrees of freedom 14, we are checking where this 2.72 lies. In degrees of freedom 14, the value 2.72 lies between the alpha value, lies between 0.01 and 0.005. So the p-value, so this is called as p-value. The p-value lies between 0.01 and 0.005. That is, the p-values greater than 0.005 and less than 0.01. Okay, so like that we are calculating the p-value. Once p-value is calculated, we are checking the value of alpha. If p-value is less than alpha, here the alpha value is 0.05. So here the p-value is less than alpha value. So we can reject the null hypothesis. So reject null hypothesis if p-value is less than alpha. So here we are rejecting the null hypothesis. Okay. So this is how to conclude the decisions based on p-value. So for the first problem, again that we can make a conclusion based on the p-value. So in this problem, the mu naught equal to 200 and the alternate hypothesis mu is not equal to 200, and how we are computing the p-value. So here the p-values, that is the number of observations, it is 10. Number of observations it is 100. Number of observations here it is 100. Then the computed value is minus 0.979. So in degrees of freedom 99. So here there is no value 99. So here seeing closer to 99. So closer to 99 is 100. So in this 100 we are seeing It is 1.290. 1.290 is for this point 2. So in this table we are not having less than value, that is here, that is a p values greater than 0.2. So from this table we can conclude that p values greater than 0.02. So hence here this p values greater than alpha values 0.05. So here the p values greater than alpha value. So there is a risk in rejecting the hypothesis, null hypothesis. So we are accepting the null hypothesis, which implies that population mean is 200. So thank you.